The first thing I want to say in this video is thank you once again to Manic08 for discovering the 2 errors I had in my positive and negative square root video. The reason why I'm not going to take the video down, and I'm not going to really give them, you wanted me to post a video response, and that'd be fine, except for the fact we're trying to use this video as a test to see if people are actually paying attention and discover the mistakes for themselves. I'd like to see them try to do it on their own instead of me just constantly helping them out. But because I know that there are a lot of people that will follow me from front to back, I know eventually they'll discover this video, and when they do, they'll get the right instruction. So whether they follow me from front to back or they start questioning what I have done in my videos, either way, that is quite a learning experience for them, and I don't want to disrupt their learning experience. Okay? So it's not that I don't want them to have the right answer, I just want them to fight for it. Okay? It's not a matter of whether they ever have the right answer or not, it's a matter of whether they're fighting for it or not. Okay? So that's why I'm not doing. Now I have left them a clue, and hopefully they'll snatch up on that clue and they'll start thinking about this stuff, but I just don't want to just suddenly give it to them. I want them to try to find it out for themselves. If they struggle for it for themselves, they'll most likely remember the experience, and that will help them better in their mathematics than if I just suddenly give everything to them. Okay? But what really surprises me with 2 mistakes in the same video is how many people just accepted it. They didn't even think to question it. When you're talking about remedial math, that's not a big deal because, you can guess at it and you're probably right. But when you get to calculus, things have to be far more precise. And I know exactly what I'm talking about. I am a data processor, so I know how precise things need to be. Okay? So, what shocks me is that over 600 people, not only on... this is a combination of what was on... See, I posted this video not only on YouTube, but I also posted it on TeacherTube. Over 600 people watched it, and until now, only you caught the mistakes. Makes me wonder about these people. They may just simply not know. They may just simply not even care. But it's interesting. It really tells me something. It tells me that there's a reason for me being here, and there's a reason for me carrying on. So, anyway, I'm going to tell them about the 2 mistakes, and hopefully they'll learn from this video, especially if they continue to follow my work, which I hope they do. They should. I mean, if I'm posting one video and they like that so much, they should follow my work all the way to here. And that really should get them motivated to come here. So, the first mistake I made. This is a real dumb one. The square root of 1 is 1. Because 1 times 1 will give you 1. It's that simple. That was a stupid, honest mistake of mine. I was tired. I never gave it a thought. There you go. Now, what is a prime number? Well, a prime number is like this. You have your prime number, which 7 is a prime number, okay? And 7 times 1 will give you 7. But no other number times any other number will give you 7 except 7 and 1. 7 times 1 is 7, but no other number times any other number will give you the number 7. Okay? What does this mean to you? Well, first of all, I had discussed in that positive and negative square root video that when you take the square root of 25, you get 5 times 5 or negative 5 times negative 5. Okay? And that is true. So, if you square root a number and the answer you get from square rooting a number is not a decimal answer like these 2 right here, and I'm going to discuss these 2 in just a second, then that's a guarantee, like 25 here, that it's not a prime number. Let me say that again. If you have a number like 25 and you take the square root of it and the answer you get has no decimal whatsoever, no remainder, no nothing, then that is a guarantee that that number is not a prime number. That's a guarantee. Now, What if you take the square root of a number, say like 7 or 8, either one of these, and you suddenly get a decimal answer? Well, it is possible, because obviously if you take the square root of 7, you get a decimal answer, and 7 is a prime number. It is possible that the number you just square rooted is a prime number. However, as you'll notice here, the square root of 8 is not a prime number. 8 is not a prime number. And if you square root it, it's still going to give you a decimal answer, as you can see right here. Okay? So, not every time when you square root a number and you get a decimal answer is that number there going to be a prime number. This one is prime, this one is not. But look, they both gave you decimal square root answers. Okay? So, you're kind of using this as a technique to see if you have a possible square root number. And because you ended up with a decimal answer, it is possible that these numbers here are prime. This one happens to be prime, this one is not. Okay? So, is there another way to tell if a number is prime or not? Yes, there is another way to tell. Okay? Obviously, any even number that you get, whether it be 528 or 1,632, can be divided by 2. Okay? Any number that can be divided by 2 is an even number. And so, all even numbers, you will not find a prime number that's even. There are no primes that are even, because they're all divisible by 2. Any number that is even is divisible by 2, so therefore, they're not prime. Any number that's divisible by 3, 5, or 7 is not prime. So, if you take a number and you try to divide it by 2 and it passes, or you try to divide it by 3 and it passes, you divide it by 5 and it passes, you divide it by 7 and it passes, then that number is not prime. So, you have two indicators. One, if you have a number that can't be divided by 2, 3, 5, and 7, or two, and 2, a number that when you take the square root of it, ends up with a decimal answer, that is a pretty good indicator you may have a prime number. That's not a guarantee, but it's a good indicator, and it's worth investigating further. Okay? Now, here's the ironic part. 2, 3, 5, and 7 are all prime numbers. Every one of these is a prime number. Even though other numbers can be divided by 2, 3, 5, and 7, these four in themselves are prime numbers. But that does not end our discussion of prime numbers or positive and negative square roots or anything else like that, because we're going to go into number theory. And when we do, we're going to talk about this a lot more extensively. And eventually you're going to come up with a formula that will absolutely guarantee you that some number is actually prime. Okay? We're going to present theories that will actually show you that certain numbers are actually prime. And this will be covered in a future video, so I want you to stay tuned. I'm hoping that once people watch this positive and negative square root video, that they'll come over to this video and watch it and learn further. And, like I said, there will be yet another video after this that will go even more extensive into prime numbers. So, don't think this discussion is over with by any means. It certainly is not. I have actually left a clue on the positive and negative square root number, hoping that people will pick up on this and come over here and learn. Maybe they will, maybe they won't, but we're going to give it a shot. I will tell you more in a future video, so stay tuned.